Data Skeptic mini episodes provide high-level descriptions of key concepts related to data science and skepticism. Today's topic is the Paxos protocol.
All right, Linda, so today we're going to talk about Paxos. Paxos is used for solving consensus in a network of unreliable processors. Now let's break that down to what we mean. Let's start with network. You know what I mean by a network?
I guess more than one.
Yeah. I mean it in a distributed computing way, that maybe you have a database or several databases. They all want to collectively share all the information in your system. So what would it mean for the network to be unreliable?
Well, you can't count on it.
Yeah, that's exactly right. So you can't count on a machine in a network because maybe it goes down, it crashes, it has a mechanical failure, or maybe there's some problem with the network, its messages aren't getting through. Could be anything, but one of those nodes could be unavailable, therefore unreliable. And now what would it mean to have consensus across a network? This is probably the hardest one to guess.
This is something I encounter at work every day.
Yeah.
It means alignment, everyone agreeing on the same thing.
Technically, you're correct. You're experiencing disagreements. Differences of opinion, maybe, is the way to put it. A disagreement in Paxos is more like, well, I observe the value to be 5, and another system says, I observe the value to be 7, and then you have to establish who is correct.
Well, that's the same with opinion. You have to discuss who is correct.
Yeah, so in networking and distributed systems, we're going to use the Paxos protocol. I may slip up and say Paxos algorithm once in a while. It's technically not an algorithm, it's a protocol because it just has some loose specifications and one could implement an algorithm that fits the Paxos protocol. But here's how I thought we could relate it to our everyday lives. Imagine, as one might do living in Los Angeles, that some incredible, massive disaster, some SimCity scale disaster happens. And sort of this end of days scenario here in LA. Now, we have a pretty good block here, right, where our house is?
We have a block of neighbors that I do not know.
Well, we know some of them. We're going to get to know them more. We would all, let's hopefully band together, pool water and resources, weapons if we need to. We'd have to become kind of a pact to stay safe, right, and keep in touch, maybe tell people where it's safe to go, where it's not safe to go. That information has to be scouted and shared and things like that.
Sure, we would make a pact.
So imagine now that's our new reality. It's Mad Max world, and our block tries to take care of each other. And we have no cell phones because the cell system is down, no electricity. How do we share information? How do we keep in touch?
I don't know. I guess we got to do it the old-fashioned way, talking to each other.
Yep, but not everybody's going to be around all the time, right? Some people are going to be out hunting, I guess, during the day, and some people are up at night.
Yeah, I mean, in the movies, I think they say something like, when the sun sets, or when the sun is in this angle of the sky, meet here.
Yeah, you could try and have a scheduled meeting place, but if everyone's asynchronous, that won't always be possible. Some people can't make that meeting. What are some other challenges that we might encounter? Getting everyone informed about where it's safe to go and where the water is and what the rations are and stuff like that.
I mean, if it were a zombie attack, people might not return.
That's right, yeah. So if it was zombies, let's say we hide our rations and you only tell one person where it is. If that person gets bitten, then the information is lost.
I mean, first of all, I feel like there's like a level of trust that has to happen.
Yeah. We don't assume any of the neighbors are hostile, as Paxos would kind of makes that assumption.
So that means you could trust them? That's different from trust, hostile and trust.
So yeah, I guess it depends on what we mean by trust. So we trust them in the sense that they're not lying to us, but we don't necessarily trust that they have the most up-to-date information. Let's say the updates are ordered as they are in Paxos. Someone would say, well, I have up to update 19. And then I would say, oh, well, I have update 21. So let me just give you the new update. And you should trust that mine is correct because I have newer information than you do. Mm-hmm. We can have failed nodes. Like you said, somebody becomes a zombie. So the problem Paxos wants to solve is to reach consensus. A couple of steps to do this, and we'll go through it in a few more details, but the general outline is you pick a leader, maybe like with round robin, and so that changes every time. Everyone knows a deterministic way of who the leader is. So when people have new information, they bring it forward. The leader assesses it, passes it out to everyone, waits for acknowledgement.
So I feel like in the real world, the leader is very important.
Definitely.
So how in Paxos would we pick a leader?
So you have like a picking strategy, like let's say round robin can work where everyone knows the order and then it just switches day to day.
So is that determined by Paxos?
Paxos is a protocol. It just says that there's a deterministic way of picking the leader all the time. There's a lot of interesting things you could explore on leader selection. I think the simple one would just be like round robin.
So he's saying it's like duck, duck, goose, but you go in the order. I think my example is more clear.
Really? You really do? Okay, we'll
I
go
think
with that.
people know duck, duck, goose more.
Okay, duck, duck, goose it is then.
So a leader, for example, they're not determined by who's most qualified to lead.
No, so in this case, yeah, we assume every node is basically created equally capable, because all they have to do is follow the steps of Paxos. So here's what those steps are. Everyone has to kind of follow them. In any given update period, the leader would ask for updates, and then everyone who's present would report their updates. So the neighbors first acknowledge the leader. We say, yes, as far as we know, you're the one who signed up to be the leader right now, and here's all our updates. And then the leader considers all the updates, and if, let's say, there's no contradictions or anything to work out, then the leader would say, all right, I've collected all the updates. I'm now going to report them back to you. And you would pass out all the updates to all the people. And then they're like your witnesses then. So they say okay, new information was brought here. The leaders passed it out to us. Now we all acknowledge that we've witnessed this new information. And then as soon as the leader hears back that the witnesses have accepted it and acknowledged it, then the decision is made. The new information's there.
And what does accept and acknowledge mean?
More or less the same thing. Acknowledge is just a message back saying I heard you. Accept means sort of written into the permanent record, I guess. So the reason acknowledge is important is, let's say the leader had to give out information about where the food, the rations were hidden, or the water was hidden. Everyone should know that, right?
I mean, if they're trustworthy,
Yeah.
yes.
So let's say the leader just wrote it on a piece of paper and nailed it to a tree. Now that information is available, anyone can go look at it, but the leader can't be sure everyone got that information. And what if the leader had to cut the rations? You want to make sure everyone knows the information, so you have to wait for an acknowledgement. But then actually there's another problem of what if you did get the information, but your acknowledgement didn't get back to me? I didn't hear you. Or maybe you sent someone to tell me you acknowledged it, and that person got grabbed by zombies along the way. And there's actually other famous problems in networking about you can never perfectly solve the acknowledgement problem, because it might always be possible that the messenger who's acknowledging the acknowledgement could be lost, or the messenger who's acknowledging the acknowledgement of the acknowledgement could be lost. If you know the reliability of your channel, you can predict the probability that an acknowledgement would fail.
And then again, going back to it, everyone agreed at a set time to make these updates.
Well, so that's actually an interesting point. Paxos works on a more complicated system where the updates are asynchronous. I might not be available for the meeting, but I still have important, or I'm going to be late or early and have to go, but I still have my updates. So the leader manages collecting them all and distributing them back out.
Does acknowledgement have to be immediate?
So it has to be within one update interval period. So there's also some timing to this. There's kind of a lock sync timer on it. There are different epochs and they're all ordered. So we enter an epoch, updates are submitted, hopefully they get accepted, and then the epoch ends and everything's finalized.
And then what if they're not accepted during that epoch?
So that gets into some more complicated stuff that's probably a bit much for a mini episode, but has to do with if maybe there's too many updates in one time period, then there's some failover ways of managing that. None of them get accepted and we try again the next time, basically, I think is the standard approach in the protocol.
To me, it just seems like project management.
Oh yeah? All right, your specialty. So tell me why.
Because in all project management, to basically make a decision, you are going to have a decision maker or a stakeholder. And then you're going to have teams of people who are advising them. If you do X, the result is Y, which is optimal or less optimal or whatever. Or here's the amount of risk to accept. And then that decision maker makes a decision.
Yeah, there's some analogies there, but the decision maker doesn't rotate, does it, in your line of work? There's one consistent leader?
No, but what's interesting is that you have regular updates at agreed upon time, which is typical.
That's what I'm saying. There is no agreed upon time. It's asynchronous. But one other misalignment here is that in the network example, we expect all the nodes are pretty much equal, whereas you have specialists. You have probably only one person can do a particularly specialized task, and you can't risk losing that node.
Yeah, I guess we don't have, I'm going to use a word that you guys know, redundancy.
Yeah, redundancy is very good.
Yes, I'm very good. I know.
No. It's not always there in project management, though. You don't always have a redundancy.
We don't have redundancies because that's expensive.
Yeah.
In the real world.
And not all nodes are created equally either.
I don't know if the word's equal, but not all nodes have the same role.
Yeah.
What I'm telling Kyle is I could have invented Paxos.
Oh, yeah. Well, maybe you did. When did you come up with this idea? Because it's a very new idea.
Well, project management has definitely been around, like at least the PMI certificate. I feel like that sprang up in like the 80s, if not a little bit before. I don't know.
Yeah. So Paxos, I think, was invented in 1995. Which is surprisingly late because it could have been invented a long time ago. I guess there weren't distributed systems, so no one was thinking about it.
Yeah, then they took a hint or two from project management.
I don't know about this. I think you're overextending it a bit.
Nope, I'm not.
Paxos also wants to get to consensus. It eventually wants all the nodes to have the information, whereas you don't necessarily need consensus.
We need consensus to move forward on a project.
No, but the graphic designer doesn't have to know what the marketing plan is for 2017.
There's consensus among certain things like the specs, the functionality, and the features. Otherwise, people are building things that do not match and align.
But it's not full consensus. Your nodes are more predictably unreliable than Paxos is aiming at.
How so?
Because generally, like no one, with very rare exceptions, no one just gone one day, bitten by a zombie.
Sometimes people are on vacation and don't tell me.
Yeah, but you also will predictably know when that node's coming back online. Aha, that's why it's not Paxos. Because you could be like, well, we need that information, but they'll be back in 2 weeks and we'll retrieve it then. Paxos has to worry that a node might never come back.
Well, sometimes people are sick and they don't tell us when they're coming back.
Yeah, that's true, but you generally know they will. Okay, so just to recap and wind up, Paxos is it's a protocol, and there are lots of algorithms that can follow the protocol. The problem it's solving is how we get machines to reliably reach consistency when the network can be unreliable and nodes can disappear, and it goes through these steps where the leader gets selected, everyone acknowledges them, the updates are reported, the leader collects, aggregates, sorts them out, distributes them, the witnesses accept, and then the decision gets made. So those steps give us the redundancy necessary to make sure that the network is reliable in distributed fashion. So until next time.
Well, I do have one question.
Okay, yeah.
So in our marriage, Kyle,
Yeah.
I'm constantly asking for updates on
I
certain
give you
things.
updates.
For example,
Right.
when you have to get the car serviced, I'm like, what's
It-
the update?
Well, there
Or,
isn't one.
If you're going to change the garage or
Yeah.
something, what's
Yeah,
the
yeah.
update? Or
Yeah.
when are you going to take out the trash? And you know what? Paxos, to me, sounds like the best way to communicate.
In what way?
In that we can have an update and then we can reconfirm it and parrot it back to the
I don't
other
want to,
person.
but it's not efficient. Let's just get stuff done. We don't need to parrot back all the information.
No, you need to make sure we're on the same page and confirm it because we're our own little network.
I don't think Paxos really applies here.
I think it does.
No,
See, I'm trying to get Kyle to parrot back to me the things I say so I could feel heard.
But I'm saying actually by definition Paxos doesn't apply. It works for networks of 3 or more nodes, you see. Paxos there's an easier solution for networks of 2 nodes like you and I.
No. We
Paxos
have
is
a
not the
bird,
answer.
Yoshi. Yoshi needs to be in the know. And I think Kyle's implying that we need to have children.
No,
which
absolutely not.
I do not want children, by
Yeah.
the way, in order so we could have a network of more than 2.
So if we agree there's no children, then we're only 2, and there's a simpler algorithm than Paxos.
But what
So
about
this
Yoshi?
parroting back doesn't solve it.
Yoshi's part of this family.
But she is a bird.
She needs to be aware of what's going on.
She can't be elected leader because she can't pass along the updates.
I think she can't communicate in her own way.
All right, well, if you can train her to pass along updates and to implement the Paxos protocol, then we'll use it because that'll be a network of 3.
We just have to give her binary questions.
Yeah, exactly. Well, all right, until next time, Lindy, thanks for joining me as always.
Thank you.
And to the rest of you, I want to remind everyone to keep thinking skeptically of and with data. Good night.
Good night. For more on this episode, visit dataskeptic.com. If you enjoyed the show, please give us a review on iTunes or Stitcher.